Alright, so we're going to be solving trig equations using a calculator. So the first thing you want to do is check the mode on your calculator. Recall that you can do from 5 here on the home screen, or you can go into your scratch pad and change that. TI-84, remember, is a little bit different, so just if you need help with that, please make sure you ask me in class. Okay, so this first question, we're solving in degrees, right? Because it says 0 to 360. So I'm going to come over and I'm going to check my calculator and I'm going to set it for this entire time, right, to be degrees. I definitely want to make that my default. Okay? Alright, so then it says isolate the trig function. So here on number 1, the trig function is isolated. It is the only thing over here on the left side of my equation. Here on the left hand side, that's just sine theta, that's already isolated. If you notice here on number 2, there's something with the trig function, so we'll have to do some more there. Convert reciprocal functions, put a note right there. That is only using older calculators that do not have the reciprocal functions. Okay, so we won't have to do that. All right, ignore the sign of the answer and use the inverse function to solve for the reference angle. Okay, the inverse function, that's something we're going to introduce today and talk about. And then once we know what alpha is, we can place it in the correct quadrants for the sign of the trig function. Okay, so let's start off. Sine of theta equals negative 80.82. We have isolated the trig function, and then we're going to ignore the negative, right? And we're going to use the inverse function. So we're going to say sine inverse, okay, of 0.82, because we're ignoring the sign. Okay, so that's what we're going to put in our calculators. So if you'll just go into your scratch pad, use your trig, sine inverse, so that's right here, and we're going to put 0.82. Enter, and it tells us it's about 55 degrees. Okay, so that's approximately 55 degrees. Okay, so now where is sine going to be negative though? Okay, so sine is negative in the third and fourth quadrants. So if our alpha is 55, okay, then we want to come away from the x-axis in the third quadrant 55 degrees. Okay? So we're at 180 and we'd add 55. So that's going to be 235 degrees. Okay? And then we're in the fourth quadrant. We're going to come here 55 degrees. So we want to do 360 minus the 55 degrees. And we get 305 degrees. Okay? So theta will be, could be 235 degrees or 305 degrees. Looking at number 2, right, now we have to remove this 5 because that's keeping cotangent theta from being isolated. So if we divide by 5, we know that cotangent theta is equal to 12 over 5. Okay, so we do the inverse of cotangent of 12/5. So we come over to our calculator, we choose trig, inverse cotangent, and we type 12 divided by 5. And we hit enter, and we get 22.6, so we'll call that 23 degrees. That's approximately 23 degrees. Okay, so we look, where is cotangent positive? In the first and third quadrants. Okay, so one of our angles for theta, one of our values for theta will be 23 degrees, and the other will be here, right, if we come from 180 and we go 23 degrees, where do we end up? At 203. So 23 degrees and 203 degrees. So here, the 3 is keeping cosine from being isolated, and the plus 9. So we're going to remove the plus 9 first by subtraction. So we know that 3 cosine theta equals negative 2. So then we divide by the 3, and cosine theta equals negative 2/3. Okay, so we're going to ignore the negative. We're going to say cosine inverse of 2/3. Go to our calculator, trig, inverse cosine, 2/3, and we get 48.19, so we're going to call that about 48. Okay. But because it was negative, where is cosine negative? In the second and third quadrant. Okay, so we come back from 180, 48, so that's going to be 180 minus 48, and then down this direction is 180 plus 48. Okay. So 180 minus 48 is 132 degrees. 180 plus 48 is 228 degrees. So theta would be 132 or 228. Okay, so now we're not going to get to use a calculator. So same steps though. We're going to isolate the variable. So we add the 3, 4 cosine squared theta equals 3. Divide by the 4. So cosine squared theta equals 3/4. Alright, now your little note there says cosine squared theta means the same thing as cosine theta squared, right? So that means to get cosine, we can take the square root, right? If we take the square root, we have that cosine theta is equal to plus or minus, right? The square root of 3 over 4. Okay. Well, the square root of 3 is square root of 3, but the square root of 4 is 2, so we can simplify that to be plus or minus the square root of 3 over 2. Okay, so knowing that, plus square root cosine square root of 3 over 2, and we know that cosine is the ratio of x over r, and we've said that when x is the square root of 3, our reference angle for that is going to be 30 degrees. Okay, so alpha is 30 degrees because x is square root of 3 and it's plus or minus, which means it can be any reference angle for 30 degrees. Okay, so if you'll recall, our reference angles for 30 in the second quadrant is 150 degrees, third quadrant is 210 degrees, and finally in the fourth quadrant is 330 degrees. Okay. That sums up the lesson.